My name's Kris Skrinak. I'm the Global Machine Learning Segment Lead for the Amazon Partner Network. One of the things about machine learning, probably the single most understood thing, least understood, misunderstood, is that now data writes code. This is really important because the algorithms are free. Every major company still requires that their scientists publish papers. They go into the public domain. You can download sample code in every framework, TensorFlow, PyTorch, MXNet. So the algorithms are free, but the data writes the code. And this is a change in software. It's a change in software development. At Amazon, we have the broadest and deepest set of capabilities in machine learning. We describe it by this figure here as sort of a cake, where the icing on the cake are AI services that are available simply through RESTful calls, just like any SaaS service. So without any experience in machine learning at all, you can do computer vision, you can do forecasting, you can do natural language processing. The middle layer is really sort of the biggest innovation we have right now. It's a product called SageMaker, which for the very first time prescribes a workflow from concept to cloud or device and IoT execution of any machine learning model. On the bottom layer, we have sort of the nitty-gritty. If you're a data scientist and you spend your day with Jupyter Network or exploring new algorithms, we have a non-prescriptive approach. We support virtually every aspect of machine learning from, once again, TensorFlow, PyTorch, MXNet, and all the new things that are coming up in this area. So to me, right now, this moment in time feels a lot like 1994. Do you remember when the internet was coming on stage and everybody was saying it's the new economy? Companies like mine were just coming of age. Everyone was saying it's the new economy except for one group of people. That was the economists. So for a moment, I'd like you to think like an economist. Whenever an economist looks at a breakthrough innovation, like machine learning, and by the way, I always use the expression machine learning. The joke is, if it's in PowerPoint, it's AI. If it's in Python, it's machine learning. That's pretty true. Machine learning is real. AI gets a little bit hard to define, a little bit nebulous. But once again, back to the economist. When he looks at an innovation, he takes out all the sex, drugs, and rock and roll and asks one question. What does this make cheap? What does this make cheaper? Now, if you ask a computer scientist about the history of the semiconductor, he'll tell you it started in tubes, they were reduced to transistors, yada, yada, yada. If you ask an economist, he will say it made the cost of arithmetic cheaper. And because that price went down, we loaded a lot of other things on top of it. Right? So I have a question for all of you to consider right now. What does AI make cheaper? Well, I'm going to answer that for you. It's predictions. And it's all about predictions. Nobody here ever got a message that said you have a 98% probability that you have new mail, right? It's heuristic. It's binary. We either have new mail or we don't. But in the world of machine learning, everything is predicted. It's somewhere between 0 and 100% of probability. So that's the first important concept, right? The second is what makes those predictions so special. Well, predictions are they're embedded in every decision-making process. So every industry, from media and entertainment to oil and gas to healthcare, can take advantage of those predictions. Now, whenever you're in a conference like this and you hear people talking about AI, just mentally replace what they're saying with cheap predictions and see if it still makes sense. That's a great guideline to tell if somebody's pulling the wool over your head. I got that from A.J. Aguilar in his book, Prediction Machines, which I highly recommend. And if we're going to talk about predictions, let's be precise about that definition. That is using the information you have to create the information that you don't have. Now, back to Economics 101, really very quickly, there is a concept of course, when things go down, you use more of them. That's supply and demand. But there's also a concept of complements and substitutes. When anything goes down in price, the complements of that thing are going to go up. So if tomorrow a cup of Starbucks coffee went from $2 to 20 cents, milk and sugar would go up. They're complements of coffee. The price of tea, consequently, would go down. So now let's look at machine learning. And what's that going to do to prices and the costs of things? Number one, the value of human judgment, now more than ever, is very, very important. And we're really not training our executives for it, frankly. The technicians, people I work with every day, understand that this is a predictive science and that it can get out of hand. If you pick 85% as your production number, but it should be 90, you're going to have unintended consequences. And people that do have that judgment are going to advance quickly. Their businesses are going to do better. The outcome of judgment, of course, is action. So what are the substitutes? Well, human prediction. This has been a big problem. Traditional analytics and data science also going down in value very quickly. So summarized, once again, data writes code. I like this other joke when Steve Jobs introduced the iPhone at the conference more than 12 years ago. Nobody in the audience said, there goes the taxi industry, but that's what happened, right? And the same things are going to happen in AI, but it's not just AI. It's big data, it's the analytics, it's the sort of infrastructure and freedom that a place like AWS gives developers, where we have choices from traditional relational database to time series to graph to blockchain, of course. It's also IoT, right? We heard quite a bit about how devices are filling the room now and doing that prediction for us. Of course it's automation, it's principally deep learning, and it's also blockchain, right? So machine learning is going to fall into basically 3 use cases: process control, insights, and optimization. And here's an interesting fact. You can really only do 3 things with machine learning. You can predict a number, you can predict a class, and you can discover a class. That's it. Now, when it comes to automation, this, of course, is very exciting. We're seeing robotic automation, both in hardware and in software in the cloud. And here's really the star of the show, right? The Raspberry Pi. Now you can do inference on a Pi Zero, it costs less than $5. I'm working with customers all over the world, implementing machine learning inference engines on these things. And don't underestimate blockchain. Whereas blockchain really doesn't provide any new functionality, it provides trust. And trust is the bedrock of every market system. And that is what makes that technology very important. One other thing that's frequently not understood is what's happening in the economy right now has a lot to do with transaction costs. What are they? That's triangulation. How do your customers find each other? The trust between them, that they're going to get paid, and the transfer of both the goods and the services that are being exchanged. Now, I can talk about this matrix for about an hour, but the reality is the sharing economy right now is all based on this notion that we have excess capacity of certain things. And technology is filling in to create this gap, to fill that gap. Things like Uber and Airbnb, right? So we're seeing economics now coming out from existing capital that's already been made. Ideas are for sale now through apps. We're going to see growth now without pulling more stuff out of the ground to make those products. Now, one thing about jobs, because that's what I have a minute left to talk about. When the Walkman was replaced with the iPhone and iPods and things like this, there were 20,000 jobs in 2 giant factories in Japan that were shut down. I don't remember anybody really crying about that. In every decision-making process, I like to say there's 4 different animals. I call it HOTS: a hare, owl, a tortoise, and a squirrel. The hare is the idea person, comes in and kind of introduces all the big concepts. The owl writes the big speech, and the tortoise can tell the person where it's going to go wrong. The squirrel is the worker, right? And when we talk about jobs in AI, we're typically talking about the workers, right? These 90,000 jobs that are out there. So, or 90% of the jobs that are out there. So what's going to happen to the squirrels, right? So it turns out there's an Oxford study that says by 2025, 75 million jobs are going to be lost in the US. That's out of 160 million. If you extrapolate that to the G7 countries, that's 170 million out of almost 360 million jobs. Now, the Amazon partner, consulting partner, Cognizant, I thought that was a little high and wasn't matching with their experience, so they wrote a book about it. What to do when machines do everything. Their estimates are about 10 to 15% of jobs are going to be replaced. And over the next few years, we're going to see 19 million, jobs in the United States go away, but 21 are going to come online through all the forces that I just described. So the writing on the wall is clear. There are choices to be made both by individual entrepreneurs, by policymakers, et cetera. But generally, the outlook is very positive and very good should we embrace this technology and manage it well. Thank you very much for your time.